Okay, in the first problem here, we are asked to subtract these square roots. And so with the first square root, we have 2 square root of 8, and I would go to the smallest square root first. So reducing the square root of 8, we're looking for perfect square factors. Perfect squares are such as 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. There's perfect squares. Okay. And now we're looking for which of these is a perfect square factor in 8. Well, 8 is 4 times 2, so we can break this up into 4 and 2. And we're going to take the square root of both of those separately. So square root of 4, this is 2 times square root of 4 times square root of 2. So this gets you 2 times 2, because square root of 4 is 2, so that's 4 square root of 2. Okay. Now, because this is a square root of 2, there's a high probability that dividing these by 2 will get us a perfect square. So if we take 32 and divide it by 2, you get 16. Is 16 a perfect square? It is. So we're going to break 32 up into 16 times 2. Square root of 16 is 4 times 3 is 12 square root of 2. 18, if we divide 18 by 2, you get 9. 9 is a perfect square. So square root of 9 is 3 square root of 2. Okay. Now, all of those are square roots of 2. So we can combine all these together. 4 minus 12 is negative 8, minus 3 is negative 11, square root of 2. So there's problem number 7. Problem number 9, same problem. Let's go to the smallest square root first. We got a square root of 5. Is there any perfect square factors of 5? No, 5 is a prime number. So let's try to divide these numbers by 5. So if we divide 45 by 5, you get 9. 9 is a perfect square. So let's break that up. So square root of 9 is 3 times negative 5 is negative 15 square root of 5. 20 divided by 5 is 4. So 4 times 5. So square root of 4 is 2 times 6 is 12 square root of 5. And then we're left with 3 square root of 5 here at the end because that doesn't reduce. So now we can combine up like terms, and looks like 15 minus 12 is negative 3 plus 3 square root of 5. Looks like that all cancels because this and this gets you negative 3 square root of 5 plus 3 square root of 5. Those wipe each other out. You get 0 as your answer. So that's your answer on that one. Number 9 is 0. Okay. If we move on to 14, 14, a little similar. We just have some variables in there. So we know that 45 has a perfect square factor of 9. I believe that's 9 times 5. So take the square root of that. Square root of 9 is 3 times negative 3 is negative 9. And we're left with square root of 5. And then the 8 to the 6th, well, 8 to the 6th is 8 to the 3rd times 8 to the 3rd. So what times itself gets you 8 to the 6th? It's 8 to the 3rd. So that's 8 to the 3rd. Or another way of saying is, how many sets of 2 are there in 8 to the 6th? So we got 2, 4, 6. Looks like there's 3 sets of 2. And we're going to take a square root for every 2. For every 8 to the 2nd, there will be an a on the outside. And then over here, 80, well, let's try to divide 80 by 5. 80 divided by 5 is 16 times 5. Square root of 16 is 4. So that's 4 square root of 5. And then how many sets of 2 are there in a to the 4th? There's 2 sets. 2, 4, so there's 2 sets. So this is going to be a squared. Oops. A squared from the a to the 4th, but there's already an a there, so that's actually a to the 3rd. Now if we combine these together, negative 9 plus positive 4 is negative 5. A to the 3rd square root of 5. Okay, we'll do number 19 in a separate video.